Then let us move to next topic, that is about stepless drives. Okay, so now we are discussing about stepless drive. So far, if you see these gearboxes, then there we have step drive. Means you get some particular RPM only. In between, suppose you decide you want 8 different speeds, then you get some 8 different speed, but in between two speeds, you cannot achieve third speed, right? So that is what the limitation of step drive. And always when you use step drive, you get some loss in economical cutting speed, right? So you are aware about economical loss in cutting speed, right? So now next we go for stepless drive. The meaning of stepless drive is you can set your required RPM. Even you can go for in the fractional value. Always you get some variation compared to theoretical value, that is due to the practical aspect. But you can also go for as per your requirement of speed, right? So that is what called as a stepless regulation or stepless drive. So first we'll be talking about mechanical stepless drive. We are starting with mechanical stepless drive, which is also called as friction drive or friction variators. Friction speed variators, right? So we'll be discussing about different friction drives. There are mainly four types. First is faceplate variator, faceplate variators. Second, cone variators without intermediate member, cone variators without intermediate member. Then third is cone variators with intermediate member. So cone variators with intermediate member. And fourth is variators with axially displaceable cones. Variators with axially displaceable cones, right? So first we'll be taking very basic configuration of friction variator, that is faceplate variators. So first we are talking about faceplate variators. So first of all, we have one circular disc and this is shaft of that shaft axis, and I would say this is input, right? And the diameter of this plate circular disc is capital D. Suppose this is capital D. So capital letters, they are generally used for input dimensions in our case. Now let me take, so this shaft is connected with the motor, and now perpendicular to this axis we have another disc, right? And diameter of this disc is small d, and shaft is perpendicular to shaft of this input shaft. So this is our output shaft axis. So I would say this is output shaft, right? Now if you look, transmission ratio transmission ratio of this drive, which is output speed divided by input speed. So I say this output speed is N2 and input speed of this is N1. Now as N1 is connected with the motor, so N1 remains constant. But as we are talking about speed variators, means we want to change this N2 speed, means speed on the output shaft, right? So transmission ratio is N2 by N1, right? Then this simply, see what is happening here, if this disc D, capital D, is connected with the motor, then rotation take place, and this disc of small diameter D2 that is also connected with capital D disc, then this rotation that goes, rotation of output shaft means rotation of input shaft goes rotation of output shaft due to friction which is at this interface, right? So this N2 by N1 is nothing but diameter ratio, means the input this D, let me change, it's a diameter ratio D by small d, right? Now we want variation. Then how variation is possible? We have flexibility to move this shaft up and down. If you move this up and down, then every time this capital D, which right now if you look, this much is capital D due to contact between this both the disc at this location. Now if you move this down, then capital D will decrease. If capital D will decrease, then what you get? You get reduction in the speed compared to N1 gradually. If you move this upward, then D keep on increasing. If D keep on increasing, then you get increase in the speed, because every time this small d that remains constant. So what ultimately you are doing, you are changing that contact, that peripheral uh, dimension at the point of contact, right? So due to that we get variation. So this d, capital D, is a variable here. This is variable. So due to that variation, we get variation in the output speed N2, right? And as we want to go for friction drive, then to ensure friction, we need to provide some contact pressure using spring. So suppose this any one disc is spring loaded, right? So always we need to provide some spring force. Now how much spring force is required? As it's a friction drive, right? So perpendicular to this white screen will be having friction force between these two discs. So normal of that friction force, that is nothing but opposite to this Fs. So always Fs should be greater than this Fs should be greater than normal to the friction force, right? So based on the material of these two pulleys, you are having friction coefficient mu, then this N is nothing but friction load divided by mu, and we also assume some factor of safety beta to ensure a regular contact due to the friction. So generally we provide more value of Fs compared to the required, right? So this factor is generally 1.2 to 1.5, means we can ensure 50 times more spring force to ensure contact between these two, right? So this is basics about the friction variators, mechanical stepless drives. So this is the basic drive, right? Now let me give some specifications of this drive. Then the maximum speed variation range possible through this drive is maximum speed variation speed variation, which is R, which I note as R max, is 4. Maximum possible power transmission P max is 4 kilowatt. Maximum possible tangential speed, that is essential to finalize the diameter range, that working range in means to finalize what should be the value of d maximum to d minimum, right? So that V max is 10 meter per second for this type of drives, and efficiency is 80 to 85 percentage, 80 to 85, right? So this is for face plate variator. Okay. Now the second type is this. If you look, this first one is for two two perpendicular shafts, right? Now suppose if you want to transmit power between two parallel shafts, but again those shafts they are offset, they are not in line, that type of arrangement we will discuss. Again, it's the same type, simple face plate variators, but for two parallel axis. This is for two parallel axis, right? So I consider one shaft here, right? And then we have uh, one intermediate member. This is intermediate member, right? Whose axis is perpendicular to this axis, right? So this is generally called as roller, or it's an ideal plate actually. And then we have one output shaft at this location. So this is output shaft. And this is line of action of input shaft. So these two are parallel, right? Now, again, here, this roller can move up and down at the roller diameter is small d, but as you move this roller up and down, then as these two axes are offset, then I would say for this configuration, I would say on input, this is input shaft, so on input shaft, the diameter where the contact is present due to this roller means this point is suppose capital D1, and at this point if you see then contact is large, this point is away from this axis, and that dimension suppose capital, this is D1 and this diameter is suppose capital D2. So this diameter is capital D2. So in this case, if you see D2 is greater than D1 because this is less compared to this. Both the axes they are offset, right? Then we can say transmission ratio TR. Here this D1 is the input, so I should say this is D1 divided by small d. So first motion transmission takes place due to friction from this D1 to this small d roller, and from roller D2, I should say from roller D2 because that is ideal. So D2 capital uh, small d2 capital D2, right? So in this way we get some power transmission, and obviously we'll be having some loss. So one time loss here, second time loss here. Then due to that we get exponential loss here if you go for this type of drive. And but ultimately, if this both will be cancelled out because it's an ideal, then we can say the transmission ratio of this drive is D1 by capital D2, right? Okay. So this is again, and also imagine two springs here to ensure a positive contact always. So one spring is present on this input shaft and second spring is present on this output shaft to ensure friction contact, right? Okay, so this drive is also having certain specifications or some applications, like it is used in cutting off machines. So some specifications of this drive like R max is equals to 16, maximum speed ratio, maximum possible power transmission is 4 kilowatt. Again, maximum tangential velocity suggested is 10 meter per second. And the efficiency is obviously dropped down due to 2 times present of loss. It is less compared to the previous case, right? So these are the specifications of this drive. So now, if you have any question, then you may ask for these drives. We keep up to this in today's session.